Good afternoon, everyone.
So Jason, hi all.
Howdy.
Hello.
Maybe we'll give everyone another 30 seconds or so to join, and then we can get started.
I think the World Cup is starting soon, so we may start losing people.
Yeah, that's a possibility. It's also summer, so we lose people because of summer as well.
Right. I'm going to say World Cup is a bigger draw.
That's probably is true. Many people will be interested in how that goes.
Yeah. I was trying to set up a meeting in Seattle last week, and the customer warned me, don't make it on the 19th. And apparently the US is playing in Seattle on that day.
Ah,
Oh, wow.
all right. Well, I have a couple minutes past, so why don't we go ahead and get started, and hopefully some folks will still join us, and um, we can incorporate any of their input. So what I had on the agenda today is the Global Summit planning. I've got a Word document that I fed into an LLM based upon last week's conversation. We can take a look at that. I did get one update um, that I'll share as well from OCP leadership that we'll have to keep in mind just for the time being. We talked about KV cache offload. If nothing's ready this week, no problem. But I also didn't want to leave it off if there is something ready to discuss. And then anything else related to the white paper and any future meetings that we want to kind of plan out and think about. So that's what I had on the agenda. But one thing that I thought I would share, hopefully everyone saw this email that came today from uh, Juan J. Lee. So they have donated the API that they were working on that they presented last year at Global Summit during our afternoon, and it's now available in the OCP GitHub. I I haven't tried to go download it. I haven't watched the video. There's a couple of links here in this email, but just thought I'd bring that to everyone's attention. That's pretty hot off the press. If you haven't had a chance to see that, like I said, I haven't had a chance to go look at any of the stuff, but maybe we can, investigate that in more detail next time or a future time. Has anybody had a chance to go look at it yet?
I just opened the repo
Okay.
myself.
Okay. All right. Well, it's there for us, and so yeah, we should when we have a chance take a look and we can talk about it more. All right, so on to Global Summit. I'll move this out of the way. So before we look at this LLM generated text, um, the one comment that I received from leadership is because they're expecting Global Summit to be even bigger than last year, it's a question mark right now if we're going to get the same amount of time on that Wednesday afternoon. It may be shortened because they need the rooms for other breakout sessions. I don't have a clear uh, understanding of when they're going to make a decision on that, but it should be fairly soon. I don't think that precludes us from continuing forward. We probably should not invite 9 people though until we are certain how many slots we're actually going to have.
What are we
But
currently planning for? Was it?
well, I was operating off of last year's template, which I believe we had 9 sessions and then the panel.
Okay.
And
Yeah,
um,
it was a few hours lunch and then
it was a few hours. It was actually right after lunch. We had a few hours and then there was a break, and then a few hours. And I'm not
No.
saying the break isn't useful because they have papers that are posted in that lower area there where people can go and look and talk to the author and stuff like that. I think that's the intent, but I'm hoping that if they're really that pushed for space, that they do away with the hour break and encourage people to go on their on their lunchtime or whatever to take a look at those papers, um, just so that everybody can get more time on stage. So that's all I know. We just have to keep that in mind. We should, like I said, we shouldn't invite 9 people right now, but I think we can safely invite 4, approximately half. And because I'm certain that we'll get at least half the time. That's pretty clear. All right, so on to this, the document I'm sharing. I took everything we put together last week. I fed it into an LLM. I iterated on a couple of times, and here we are. Outsquirted this. So I am not attached to anything here. We can modify it. We can go back and try again. Whatever makes sense. So obviously, if you're sending this out as an individual personalized message, it may need some customization based upon the person you're contacting, right? If you know that they work in DPUs, for example, then obviously, you want to craft it a little bit to focus on their DPU focus, or whatever makes sense. But thoughts on this? Is this a useful starting point for an email to reach out to people? Feedback on it, changes that we would like to see made?
The only So the first things I see, we could put CSDs just so that it's also included in the TLA listings, and then because we say PIM, PNM, DPUs, CSDs. Um, we could probably include memory wall for a somewhere here in this challenges, just as a buzzwordy thing.
Memory wall, okay. Um,
Trying to figure out how
like
to
it, like,
work it into a sentence. So.
yeah. Are you thinking like in this, somewhere in this next sentence area, or further down?
It would be in that highlighted sentence, the challenges sentence, but I don't know how to, because saying, the growing cost, power, performance, complexity of moving data, that is the problem, is just a rewording of it.
So here's an idea: in performance, power, and complexity, comma, including the memory wall, and then the hyphen. I don't know if that's useful.
That doesn't sound right.
Yeah.
Overall, I think it's a good description, who we are and what we're looking for.
Yeah.
I think this is
Yeah.
right.
Okay. And I'm happy to include memory wall. I don't have another great
I
suggestion at
wanted
the
to
moment.
include it just because it is something that people pay attention to. It is a good shorthand to describe the problem.
I'm actually rather impressed with its accuracy, given what must have been fed into it.
Yeah. Well, I mean, I uh, hand edited it a little bit, right? So it wasn't,
Okay,
you
all
know,
right.
perfectly the output, but it was close.
I'll take it to mean you had to write this all from scratch.
It wasn't quite that bad, but yeah, there was some hand editing.
Okay, okay.
It didn't go off on a tangent about goblins, so that's
Right.
an improvement.
That is good. Yeah, we don't need any tangents about goblins. So, John, thinking about the memory wall, you're thinking that the memory wall is really a synonym for these three things: performance, power, and complexity. What?
Yeah, it's performance. That's bandwidth limitation. It's a little bit different because, and yeah, because the power issue is a different problem altogether. It's saying like we want to the power issue is we would like to do what we're doing now and drastically reduce the power cost,
Hmm.
or reduce the power cost such that we can continue to scale and in an efficient way.
So, what if we just put it in parentheses right after performance? Performance, open paren, memory wall, close paren, comma, power, and complexity.
Yeah, let's try it. Let's see. I don't know what do the others think?
I think that sounds pretty good.
I don't have a problem with that addition. I'm okay if we leave it out as well, if there's someone who's strongly opposed.
I was hoping there was a way to include it in an easy way that flows nicely, just because it is a hot topic.
The biggest challenge I found with data-centric computing is trying to do all of these things in the presence of keeping resiliency a high priority as well.
Mm.
So there are certain ways of doing things where you can do them if you're not worried about losing data. But if you are worried about losing data and you need to inject RAID or erasure coding or something like that in here, suddenly it all just blows up in your face again. So I don't think it justifies inclusion here, but to my mind, that's something that always lurks in the back of my mind. Are we doing something that prevents like a true production rollout?
It is probably worth saying resiliency in the what we're looking for, uh, and at least mention it as a benefit. If someone has a good talk, a good presentation on, how they're improving RAS in these, attached device scenarios.
I don't think anyone here does. I only know of one company that's doing anything along those lines, but they can't quite seem to get off the ground.
So are you thinking added here as one of the items in this or list? Re
Yeah,
continued
measurable benefits such as improved efficiency, lower power, better scalability, uh,
improved resiliency.
improved, yeah, resiliency or reliability or availability.
Something like that, yeah.
Which word do we like?
I personally like resiliency.
Yeah.
Sure. I think that's good.
Yeah, it would be good to hear from the other like Gaurav, Pankaj, Sam.
Yeah.
They're around, but
Yep.
as a first stab, that looks good to me.
Okay.
Looks good
Absolutely. So
as a blurb that we can base, fielder emails on.
sure. So why don't I go ahead and I'll just upload this to groups.io and um, obviously everybody will get notified and they can take a look at it and we can also review it again next time whenever they're able to join.
Yes, I think it seems good.
Okay. Okay. Great. All right. Do we have anything ready on KV cache offload this week, or should we um, plan for that in a future week?
So I've been looking at prompt and context engineering workloads, like kind of recent developments for prompt and context. This is all of this stuff that happens prior to inference. Um, I'm working with someone I've worked with before in ARM, trying to hopefully get a presentation out.
Mhm.
It would be something that we could present here, that we could maybe submit for global as well. This would be, at least primarily, it would be kind of an explainer, like a primer on some of the stuff that's happened in this, pre-inference AI workflow. Um, and then, hopefully we can make an argument that there's an opportunity for near data compute there. That's something that we kind of already know a little bit. Like we're familiar with vector DB improvement, and that would be part of it. Um, so hopefully, maybe by next week, I could have a presentation.
Okay. And no pressure, John. That's not the point. It's just if you've got something, then great.
Yeah, the most difficult thing is just making sure that it's stuff that we're allowed to talk about.
I understand. It's got to get approved.
For KV cache offloading, I'm not sure who was slated for that because I was looking
Well,
at the
so
prompt
you were,
stuff.
yeah, John, I thought you were going to like work on some text that might be able to go in the white paper, but also Gaurav was going to work on something, and we knew he wasn't available this week.
Yeah.
He was going to maybe let us know next week when he might have something ready, but it won't be next week.
Yeah, ideally, I'd like to get the context of this, near data compute for context engineering. I'd like it to be a presentation, at least for us, maybe also for global, and maybe also in the white paper, as much as I
Hmm.
can get in there.
That'd be
But I
great.
don't have that right now, unfortunately.
Nope, no problem. And so maybe I didn't fully understand last week. That's what you're working on that you would be able to discuss when you get the approvals and such.
Yes, that's one of
Okay.
the primary things.
Okay. Not KV cache offload necessarily. It relates, but
Yeah, there's not much I can share about KV cache offload.
okay. Okay. No problem. I probably didn't understand exactly what you had in mind, but that's great. All right. So I assume we have nothing ready for the white paper for that anybody wants to talk about. I apologize. I don't either. Do we want to think in terms of some topics that we want to cover in future meetings? Either folks we want to try to invite or um, material we want to have our existing members try to prepare. or anything we want to talk about today, for instance, can be any of the above.
So for me, one of the things that I have been contemplating about trying to do compute near the storage of the data
Hmm.
is just what is the zoology of what we're talking about? What are the different kinds of computational work? So I know that there are lots of people who will say, all I'm looking to do is filter some of the data. So you want to read from a file or whatever it is, filter out some of that stuff before sending it back. That way you're not cluttering up the networking and all that sort of stuff. Others want to do actual programmatic stuff to the data and et cetera. I don't know that we have good classifications for these right now. And I don't know that in our minds as a group, we all have the same set of things that we're looking at, or are we trying to be as broad as possible? My fear being that whenever you try to be very broad, no one can bring it down to earth and come up with an answer. They just wind up talking in obscurity.
Mm.
So you know, if we need kind of a common glossary that says we're trying to do this kind of stuff, so let's put them in a group, and maybe there's some other groups there, and then we can figure out which ones we're actually interested in tackling. Maybe it's not all of them, and that helps gives us some uh, more stability, I guess, in terms of what our topics should be.
Hmm.
So just a suggestion for the group here.
So, so I will say we have some existing white papers, which I don't have the link handy. The previous white paper from this group, and then the other one from CXP, which was the programmability group that got folded in. Um, in terms of wideness, in terms of topic area, we're looking at kind of four large classifications for computational devices. That's the PIM, PNM, CSD, and DPU. Um, so without being, you know, without picking one or the other, are there improvements in programmability primarily, um, things that we can push for standardization that would benefit all of these kinds of devices?
Hmm.
And as for the kind of compute that they're doing, uh, we have an intuition that it's low algorithmic complexity work. It kind of started in like CSDs and it was looking at common data operations, compress, decompress, encrypt, decrypt, and then some kind of like wire filtering. And then that was also very common in DPUs. Kind of the major use case for DPUs was, can I do some kind of packet filtering
Right.
at wire speed? From the PIM world, there was a lot of, like both Samsung and SK Hynix. Um, well, I'm familiar with their PIM ISAs. They have their instruction set, their kind of limited operations, a lot of kind of simple mathematical operations. Um, Nothing as large as like a filtering or, like I guess an example would be like being able to do GIMV on a near memory device. And that's something that is potentially possible.
Hmm.
Thankfully, we are kind of focused on AI workloads. Granted, AI is fairly wide. There's a lot of moving parts to AI, but we had more focus on non-AI workloads a few years ago. Now they've
Right.
all kind of gone by the wayside.
Yeah.
Like we used to focus more on like database improvement, which now it's interesting insofar as those databases are being used in these large AI pipelines, right?
Well, do we have a good understanding as to why those haven't taken off?
Uh, I mean, I think that for now, certainly a lot of that's been de-emphasized because everybody's focused on AI. I think prior to AI becoming the focus of everyone's attention, I think that I don't know if there's a single reason that you can point to that says this is the reason.
Okay.
I think certainly some of the things that we're talking about and trying to address in this group are applicable in terms of a unified API that would work for all of these different offloads. Right now, they're largely custom and proprietary for anybody who creates their own, and that's never a recipe for success.
Yeah. My concern about all of this is that when I take a look at some of the different things that have been tried, um, in terms of moving compute near storage, the different things imply very different hardware required to do that. Like how much memory do you need? How much compute do you need? And all that sort of stuff. So to some extent, I would definitely appreciate understanding what workloads are best in a streaming platform where you don't need a lot of memory, and you just can stream that data through and process it, and everything should work great. And in other cases, if you're trying to do something very complex, like trying to do the equivalent of a join inside of an SSD or CSD or something like that, that's going to require a lot more memory and very different kinds of hardware design. So I kind of feel like I don't want to talk about them in the same sentence because you wouldn't use one for the other. Or if you understand what I'm saying, just the solution or the hardware that gets designed for these things aren't necessarily going to work for everything. That's kind of why I want a better description of what we're category of better categorization of what we're trying to work on, and then we can kind of focus on one at a time. But I don't know. Maybe I just need to read more of those papers and see if those are sufficient to the task.
There was an effort in, and I think the DCC white paper, I remember there was a table, um, kind of laying out a bunch of different workloads and then
Mm.
how the various NDC options, the different kinds of NDC devices and programs would be able to what would affect that workload.
That
Yeah.
is true, yeah, and that table was somewhat incomplete because it only focused on how the particular technologies that we've talked about, computational storage, DPUs, in-memory compute, near-memory compute, apply to those types of examples. And so obviously, if it doesn't apply, then that
Mhm.
row or box was empty.
Okay.
I would
Yeah.
say in my own research, and I, I don't I don't know if this is certainly true, but it seems like the best use is low algorithmic complexity. Um,
Hmm.
that you really only come out ahead in terms of well, this is, I should say, in terms of um, latency or bandwidth reduction performance. The separate there's a power argument which is kind of very different, and the power argument says that you should effectively do as much compute as you possibly can near the memory because you're trying to keep it all with internal bandwidth, right? That as soon as you ship it out externally, if you leave the device and go to the external host, then you've ballooned your power budget up by, an order of magnitude or more.
Yeah, but I've often found that the challenges with those problems are that you need data that may be on a different device. So the
Yeah, it would
value
only be for workloads that fit on the device, like
exactly,
that
and
there is
that's
no necessary external action.
right, exactly.
And then that is possible if you're able to partition your work such that you can always fit only the relevant information on each
Yeah,
device and that they're able to work independently.
right. Yeah,
Um,
and this is where I feel like we need to constrain the problem a little bit more so that we have something that we can chew on. If we try to take on the world, we're just never going to get anywhere. So if we just constrain it to something that's relatively simple to work on, but valuable, and we have to figure out what those mean, um, then we have something that can show initial success, and then we can start working on the bigger problems later.
the um, the vector DB offloading is one of the strongest use cases that I've seen. This is a graph structured database. The major operation that you're doing is graph walking, which is a lot of pointer chasing,
Yeah.
and you're getting a huge performance uplift because you're effectively latency bound, and you're
Yeah.
able to do all of this pointer chasing on the device without leaving the device.
Yeah, I know that that's incredibly valuable, but it also presumes that all the data for your graph is on a single device.
Yes, or yeah, at least as much of this graph as you can traverse just on this device.
Right, exactly.
And vector DB is kind of even more benefited from this than normal graph DBs because that vector DB is all about clustering. So,
Hmm.
you very quickly are leaving, if you're looking at something like HNSW, this is hierarchical navigable small worlds, that
Yeah,
algorithm.
yeah.
If you have HNSW, very likely your first few hops, your first few layers are going to be moving to different machines, like
Hmm.
routing.
Right,
And then once you're on that machine, the entire subgraph beneath that is all local. And then you do
right.
the remaining however many hops to get to the data. Or to come back with it's a nearest K is usually how it's used, right? So
Yeah, I've seen that problem, and it does intrigue me from a computer science standpoint. I don't know how to do it in practice, but it's definitely an interesting problem. And it's not unlike doing, physics simulations, where you have, trillions of particles, but you're basically taking each problem and sectioning it down into, a billion particles per, and then trying to divide it out amongst many CPUs or whatever. So it's a very similar problem. And maybe that vector DB one is kind of an interesting one because pointer chasing is incredibly power intensive for relatively low value for that power. Um, Maybe we're getting too specific at the same time, but yeah, I think I hear what you're saying, and it's a very interesting, definitely a very interesting problem.
yeah, there are others. I think that's probably my favorite use case. If I were to pick one to demonstrate the benefit of near data compute, then I would probably pick that.
Right,
And it's generic across devices because I could be doing this on a DPU, I could be doing it on a
right.
CSD, I could be doing it with some kind of, like a CXL attached near mem compute device if I had some cores on this CXL attached device. Maybe
Well,
there's a way to do it in PIM. That's maybe the most tenuous, but I'm not sure how that would look if I were to try and accelerate that with PIM.
I think we would have to work with some vector DB company for this. I don't know if you have any candidates.
So Garov has talked about this problem a lot, and Marvell they have a device that can do it, the Structera A, and
Okay.
he's presented on that in the past.
Hmm.
Um, and I think that was Marvell and which memory company? Someone jog my memory. The collaboration. Who was it who did Garov present with last year at last Global?
I'm not sure.
Yeah, I'm drawing a blank at the moment. Let me see if I can figure it out.
Was it SK Hynix? I can't remember.
Yeah, SK Hynix and Samsung.
Okay, yes, thank you. So that was, demonstrated pretty well by them last year.
That
There are
that was in
other
terms of
workloads that we
doing
can focus on, but sorry, go ahead.
this was when the data was stored on in DRAM, correct?
This is the Structera A is like a CXL attached memory device that has some cores on it as well.
So this is kind of
So there's host memory and then there's also attached memory.
right.
And you can partition it such that you have many of these devices, one host with 4 or 10 of these CXL attached memory devices.
Okay, because I've been asked for analysis of how to do these sorts of queries on a vector database where the size of the database is approaching a petabyte, and that's something you definitely don't want to do in DRAM.
Yes.
Um, so okay, well, I mean the structures are all there though, right? How you split out the problems, how you create the
Yep.
small worlds. Um,
Yeah, from a petabyte down, it would, there'd be quite a bit of routing. You'd probably
right,
have a few layers of disaggregation before you even get down to something that looks like a host with some attached devices.
yeah, yeah, okay.
So it sounds like that there is not something we need to work on here then. Is that
Well,
where
I
we've kind of
think
landed?
we're going to need Gaurav to guide us on this one. If we
Okay.
wanted to do such a thing on top of SSDs, because the problem is big enough to want to store on SSDs rather than DRAM, I think the benefits of this could be better than on DRAM. Um, but we can't take any software just right out of the box and make it work. So we'd probably have to have some amount of effort put into this. So we might need to talk with Gaurav about that and see if he knows of people that would be interested in working on this sort of a test.
Sure.
Right. I enjoy that it's a forum of, we're all looking at this problem from different avenues,
Yeah.
Right.
a bunch of different companies that are all, providing different components for this. Certainly, I think the idea, the hope is that we can output some kind of standard that would be used to help the programmability a lot.
Yeah.
That's been historically kind of the largest problem is that even in the cases where there's strong, compelling evidence that you can use these accelerators and get pretty good performance uplift, the problem is, yeah, what do I do to program it? And
Right.
it's very non-obvious. Um, you are you're going to have a very hard time converting existing programs to using near memory compute if the original program wasn't written in a way that was aware of like memory placement, like
Hmm.
the difference between host memory and some kind of attached memory or DPU or CSD.
Yeah, it's impossible then.
Um,
Well, I shouldn't say impossible, but it
Very
would
difficult.
require a lot of
Yeah,
reprogramming.
or
Uh,
yeah, some kind of compiler wizardry that is rare to find.
well, I do think you've hit upon it. And this is something I've noticed over my years in the industry, which is software people are software people and hardware people are hardware people, and never the twain will meet. And we're basically looking at something that's right at the intersection between the two. So generally, when software people come across a problem, they try to find a software answer, and vice versa for the hardware people.
Hmm.
So trying to get multiple different mindsets together to try to think about the problem, globally is going to be hard. And hopefully we can find some work that's already been done in this and just build upon that rather than trying to build it all from scratch.
I wish Pankaj were here, but the kind of, one of the major goals is if we can get software people thinking about open data and open compute standards, as in defining their memory with, commonly used open standards like Parquet and Arrow, especially Arrow. And in the same way, kind of write their computation with these common compute standards, then suddenly there's a lot that opens up. Because
Yeah,
if we have some faith that the input programs are going to be using these common verbs and common shapes, then we can do a whole lot on the hardware side that expects that.
right.
But there has to be, yeah, some kind of meeting between between the two. Otherwise, the only thing that historically works is something like NVIDIA, that they make their own accelerator and they make the entire software stack for it, and it's entirely proprietary.
Yeah. And I think that's not what we're looking for.
No, I think we're looking to
Yeah,
move away from that.
yeah,
Yeah.
we would like to foster openness and make sure that there can be more than one player.
Right.
Mhm.
Yeah. Okay.
So good discussion. Other topics that folks would like to bring up today?
None for me.
Okay,
Like I said, hopefully I'll have something by next week to present for everybody.
sure. That'd be wonderful. Thanks, John.
Yeah.
All right, well then maybe we just go ahead and give 17 minutes back to everybody this week, and we'll catch up next week.
Okay.
All right.
Thank you very much.
All right.
Thank you.
Thanks, everybody.
All right. Bye.
Thank you.